So like I said, like Kelly said, my name is Mike Brennan. I'm a PhD candidate at Drexel University. I should mention, yeah, I am also a technologist at the Federal Trade Commission, but I just want to make it clear at the outset of this talk that I'm here representing Drexel University and not representing the Federal Trade Commission. I'll be giving a couple slides, just kind of a little bit about my work there, but it's purely about the kind of job I do and not what we do. I'd be happy to informally discuss any of that work offline, but I'm going to focus on my academic research in this talk. So the talk I'm giving today is called Adversarial Stylometry, Attacking Authorship Recognition to Preserve Privacy and Anonymity. And now, stylometry is not a word that many people are familiar with, and like some of you might have heard me mention before, it's not a word that even any spell checker I've ever known is familiar with. So let me give a brief overview. By the way, I have some notes on my screen here, so I'm kind of trying to pull both slides at the same time. I might get a little confused. So in this talk, first I'm going to define stylometry, or authorship recognition as it often is known. And I'm going to go over some brief history of it and explain some current methods, explain why it's important. And then I'm going to talk about the potential privacy and anonymity threats that stylometry presents. I'm going to talk about our study that had to do with attacking authorship recognition, attacking stylometry in order to preserve privacy and anonymity, where we found that despite the fact that authorship recognition systems are very advanced and can do a very good job at identifying your writing style based on the linguistics in text, it is actually possible to fool these systems and to pretend that you're someone else, even a famous writer. And just as a quick postscript, I'm going to talk a little bit about my time in Washington, just a few slides, because I like to include that in all talks I give now to kind of show that there are some other avenues for computer scientists other than traditional industry and traditional academia. So first, what is authorship recognition? The basic question in authorship recognition is who wrote this document. You have some document of unknown authorship, you have some text there, and you want to figure out who wrote it. Now, stylometry is actually a subset of authorship recognition. I use these terms interchangeably in this talk, but it's important to recognize that stylometry is a specific kind of authorship recognition. And that's authorship recognition that looks only at the linguistic styles that are exhibited in a document. So we're not talking about the contextual features or the content of the text. We're not talking about when it was written. We're not talking about handwritten style. We're just talking about the linguistics of it. The word counts, the word frequencies, sentence structure, grammatical measurements, things like that. And stylometry works in that you can identify an author based on their writing style because individuals have unique writing styles based on their individual method of learning language. We all learn language individually on our own and through a variety of different channels, and because of that we all develop a unique sense of speaking and writing that is our own. It may be subtle in differences between different people, but it is there. So again, in this presentation I might use these terms interchangeably, but stylometry is the proper term. I'm not using this. Oh yeah, see, I just did it actually. Okay, so adversarial stylometry. So in this talk, I define adversarial stylometry, and I'm saying adversarial stylometry is the application of deception to a writing style in order to affect the outcome of stylometric analysis. And this raises a bunch of questions, like, is your writing style even modifiable? Is it possible to attack stylometry through altering your writing style? What are the implications of looking at stylometry in this context? But I'm going to come back to this. It's something I'll come back to a little bit later. First, let's examine stylometry, the history of it, what it is, and some of the privacy implications of it. So a brief history of stylometry. The classic stylometry problem is that of the Federalist Papers. Back in the late 1700s, when the Constitution was in the process of being ratified, there were 85 anonymous documents that were written to persuade the people of New York to ratify the Constitution. And 12 of these documents, most of them have been identified, the author has been identified through historical means, but 12 of these documents have disputed authorship, and they were either going to be have been written by James Madison or by Alexander Hamilton. And stylometry has shown that James Madison actually authored these documents. And the original studies looked at the use of certain words in these documents to show that the words that were used in these unknown documents are words that Madison would much more likely have used than Alexander Hamilton. And this has been used as a data set for countless stylometry studies. Now, modern stylometry does not just look at, the frequencies of some different words, but it's embedded in modern artificial intelligence. Support vector machines, genetic algorithms, value-based classifiers. These are all current modern methods of stylometry. So why is this important? It's great that we can figure out who wrote a 200-year-old document, but what significance does this have now? Well, there's a quote here from the Institute for Linguistic Evidence that I think sums up one of the uses of stylometry pretty well. And it talks about how stylometry is actually quite important, not only in criminal cases, but in a variety of legal cases. You need, authorship is often disputed in historical contexts and legal contexts, even in plagiarism at universities. Authorship is contested, and you need reliable methods to determine authorship. There's a strong value to accurate stylometry methods. But there's also an application here of anonymity and privacy. Now, before I talk about the privacy applications of stylometry, I want to first recognize the value of anonymity. And I'm giving this talk with the assumption that most people here probably would agree with me that privacy and anonymity is something that's important. And certainly there are bad uses for it. But as this quote from Secretary of State Hillary Clinton last year says, there's a recognition at the highest levels of the value of anonymous speech. And I'm giving this talk with that assumption. If this talk is not meant to debate that issue, but if you want to talk about that offline, I'd be happy to. So going into this with this understanding that privacy and anonymity is important and valued, let's look at how it's done now. Well, there's plenty of good applications or methods for location-based privacy. We have anonymous communication software like Tor. We have very simple methods, like you just use a fake name when you want to publish something or talk to someone. But these things may be insufficient, because if you are writing something that's your own writing and you're trying to put it out there, your identity could be implied through the writing style in that text. And there's been some research showing that you only need about 6,500 words to properly leak the identity of an author through the writing style. And if you think about 6,500 words isn't a lot. Most of your employers and teachers and people across the board probably have 6,500 words. If you have a blog or a Twitter feed, you can probably combine it to get about 6,500 words. Your identity is in this writing style, it's in these words. And there's it's important to look at this multidisciplinary approach to privacy. Privacy is not just about technical and location-based anonymity. It's not just about technical means for anonymity. It's also about the content which is being produced through these anonymous channels. So I'm going to give two examples of a potential privacy threat, and I'm also going to, in that, explain the two different kind of scenarios of stylometry problems. The first main scenario is supervised stylometry. Given some set of documents of known authorship and a document of unknown authorship, you want to attempt to classify that document of unknown authorship after you've trained some sort of classifier on the known documents. And here's a scenario about this. Say you have Alice, the anonymous blogger, versus Bob, the abusive employer. Alice wants to blog about abuses at Bob's company. Say Bob treats his employees really poorly, he doesn't pay them right, he doesn't hold up to ethical workplace standards. Alice might want to publish something, an open letter detailing these abuses. And Alice is smart from a location-based privacy perspective. She uses a fake name. She uses Tor. There's no easy way to track where this post came from, where this letter came from. But if she doesn't hide her writing style, it could be quite easy for Bob to potentially obtain a few thousand words of Alice's writing. He's her employer, so presumably she's in a place where maybe she's written reports, emails, things like that he has access to. And he could use stylometry to identify Alice as the blogger. Say he has even up to 100 people in his company. There are methods out there that show with even up to 100 people, you can get 90% plus accuracy in determining the author of an unknown document. And furthermore, beyond just that, there are other methods of writing analysis that, for example, give away the fact that Alice is a woman and not a man writing this document. There's research out there that shows it's actually, you can tell quite easily in many situations the gender of the person writing the document. So maybe he doesn't have enough of Alice's writing style to test it, if it's actually her, but she's one of the only women at the company, and then he can identify her that way. Another method of stylometry is unsupervised stylometry, and that's where you have a set of documents where there's no known authorship at all. And the goal here is to cluster those documents together into author groups. This is also known as the similarity detection problem. So you have, say, 100 documents of unknown authorship, and you want to find out, oh, there's actually 4 authors here, and author A probably wrote these documents, and author B probably wrote these documents. Excuse me. And a privacy scenario here would be some sort of anonymous forum versus potentially an oppressive government. Participants in this forum might use it to organize protests. They might use it to discuss strategies. These posts could be completely unlabeled. There's no pseudonyms. You don't know the organizational structure. You don't know how many authors there are. But the government, with some savvy stylometry, could potentially figure out roughly how many authors there are, could come up with different potential author profiles, and then apply that knowledge to a supervised stylometry system. Say they want to find out if anyone inside the government is posting on this board, where they can take these author profiles that they figured out and relate them to employees of the government. So these are all hypothetical scenarios, right? But recently I was made aware of actually a realistic scenario for this. So I gave a talk about some of this work a little over a year ago at the Chaos Communication Conference. It's a security conference in Berlin. And I found out after the fact that both the head of WikiLeaks and the spokesman for WikiLeaks were in attendance in my talk. And the former spokesman of WikiLeaks, recently wrote a book about his experiences. And in that book, talked about being at my talk at CCC. And he talks about nudging the head of WikiLeaks and saying, hey, this is actually pretty interesting work, because at that time, they were masquerading as having all these employees, having these lawyers, having these people writing these different press releases and documents, but really it was just the 2 of them writing everything. And said, man, if someone had actually run our work through this system, they could have found out that it was just the 2 of us writing all these things, not a whole bunch of people. So regardless of what you think of WikiLeaks, I'm not trying to promote it or in any way, or say that it's not good in any way. I'm just saying that this is a legitimate, actual privacy concern related to authorship recognition that is out there. And I think that there could be many other instances of exactly this type of threat that could be out there that could potentially compromise someone if they're trying to maintain their anonymity or maintain their privacy or hide facts about their organization or their person. So all this, knowing the implications of privacy, the implications that stylometry has on privacy, we have to ask a question. Can stylometry be attacked? Can we come up with a means of getting around these methods of stylometry? Can we come up with a means of hiding writing style sufficiently so that it can be anonymous enough that people can publish things anonymously and not have to worry about it coming back to them? And to answer these questions, we conducted an in-depth study on attacking multiple methods of stylometry. And the results of that, we found that stylometry is actually very vulnerable to attack by inexperienced human adversaries, and that you could potentially use these attacks to promote privacy. So I'll go into some detail on that study and the attacks we used. So we came up with 3 attacks. Well, initially 2, but then we ended up expanding it to 3 different attacks. We have an obfuscation attack, where someone tries to hide their writing style by any means possible. We have an imitation attack, where someone tries to specifically imitate the authorship of the writing style of another author. And we have a translation attack, where you take an unmodified document, you run it through some machine translation software, and translate it back. And that actually last one came out as a recommendation from a number of people seeing our talk. We were asked this question, well, what if you just ran through translator? We actually found it not to be very useful, but I'll go into details of that later. But the obfuscation and imitation attacks we found to be very useful in terms of protecting your privacy and anonymity from stylometry. So the first step in this is to build a corpus. There's plenty of writing samples out there on the web, right? There's plenty of stuff available that you can run stylometric analysis on, and that's been done extensively. There's been a lot of stylometry research over the past couple decades, but no one has actually looked at this adversarial question, and part of the problem is that there's no adversarial data sets. You can't just take anyone's writing samples and then do an adversarial analysis on them. You have to actually get those same people to write adversarial passages. You have to get the people with the known authorship to say, okay, this is my attempt at hiding my writing style. This is my attempt at imitating someone else's writing style. And, as I'm sure anyone here doing user studies has known, it's hard to get people to volunteer for this kind of stuff, right? But we were able to do it. We got a bunch of people to volunteer. This corpus is available publicly. We actually got 15 people to volunteer, but this analysis is only on 12 of them because we released the study publicly and 3 people did not want their information released publicly, but the other 12 did. You can download this corpus from our website. And the method here was to have each individual submit 5,000 words. Yeah.
At some point, are you going to say a little bit about what features would you use to identify?
Yes, that's in like about 3 slides.
Okay.
Yeah. So first we had them submit about 5,000 words of their pre-existing writing from a formal source. Then we had them write a 500-word passage about as an obfuscation attack, which we asked them to describe their neighborhood. And then we have them write a new 500-word passage of an imitation attack where they tried to imitate the author Cormac McCarthy. And in that we asked them to describe their day in the third person. And these authors, it's important to keep in mind, had no formal training or knowledge in linguistics or stylometry. We didn't give them any hints as to how to change their writing style. We just said, we're going to try and detect who you are by your writing style. Go for it. Yeah.
What was their incentive to imitate Cormac McCarthy well? I mean,
so
besides just giving the instructions, how would you? I mean, I just worry that maybe many of them probably didn't care, or maybe they tried too hard. What did you?
So that's a really good point, and actually something that we thought about. So the goal with these tasks was that we knew that the only way you're going to get a good sample is if people are somewhat interested in what they're doing, right? If people don't care, we can't trust the results because they might not have really tried. So first of all, we gave them easy tasks in the sense that we wanted to give them tasks where they didn't have to think about the content, they just had to think about their writing style. So that's why we asked them to write about their neighborhood and write about what they do in their day. Because it's pretty simple to say, well, I live in a street, it's got some trees on it, it's got some houses on it, I live here and there. And it's also pretty easy to say, well, I get up in the morning and I make myself some coffee, and things are kind of second nature. We didn't want people to have to think about that stuff. On that same note, one of the main reasons we chose Cormac McCarthy is that we gave these authors a sample passage to work from, and we found that his work, well, our opinion was that his work is really easy to kind of get into, and it's fun to try and write in his style because he has this very distinct dark style. Here's a quote from his book, The Road, which was also made into a movie recently. Some people might be familiar with it. He uses this really dark, descriptive style, which, on one sense, it might be a bad idea to give someone with an author to imitate with a fairly descriptive style, but for the purposes of getting them interested in the task, we want to give something that they can sink their teeth into. So we gave them this, and it actually produced some pretty funny results. Does that answer your question?
Yeah,
I think he'll get to it also in the results.
Yeah. Well, yeah, we can bring it up again later if that doesn't answer your question. This actually produced some pretty funny results. So I have literally thousands of words of people talking about their day in Cormac McCarthy's writing style, which is pretty entertaining. And again, even if you want to download the corpus just to read through these things, they're a riot to read. And I don't think some of them were intentionally funny and some of them were not, but they all tried to seriously imitate Cormac McCarthy while talking about brushing their teeth and making coffee and talking to their partner in the morning and drinking orange juice. So it was pretty entertaining. So we feel like we were pretty successful in this. People spent generally about 30 to 40 minutes doing the whole thing, which is about the amount of time we wanted them to spend on it. It wasn't too long. We felt they were properly engaged, and we were happy with from a personal level of just looking at the writing samples, we were happy with the samples we got. Now, to go into the methodology a bit more, we looked at 4 different methods of stylometry. The first 2 were sort of straightforward machine learning methods that use these 9 different unique features to measure a general print of someone's writing style. The third method was a synonym-based method that only looked at the word choices that you make when in your writing style. And the fourth is right prints, which is we consider to be kind of the current gold standard for stylometry. It's a very comprehensive, using thousands and thousands of features, using a fairly complicated system which I'll go into a little more detail of in a few slides, to analyze the writing style and come up with these, what they call right prints of the authors. And the reason we use this variety of methods is we know one of the main rules in stylometry is that there is no one method fits everything solution. You have to find a solution that fits your data set. And we wanted to try and cover the bases on the different methods that are out there, the different kinds of features that are used, the different kinds of classifiers that are used. And so we took these 12 authors and we, did tenfold cross-validation off of random sets of these 12 authors. So we took 3 random authors here and 10 random authors and 12 random authors there. It was all regimented. I'm making it sound like this. We took. I can go into the more details of the experiment if you want, but I don't think that's very interesting. But we had regimented experiments on different numbers of authors and unique sets of authors. So here's some linguistic features that we use. And so in right prints, for example, which most of these features are from because they have the biggest thing, you look at issues like spelling. You look at the different changes in differences in spelling. You look at functional words. Functional words are a feature that is used throughout a lot of stylometry research. The idea of a functional word, yeah.
The 9 features was 9 class of features? Or
I'm sorry?
9 features?
The 9 feature set was 9 individual features.
9 individuals?
Yeah.
9, for example, words or-
I'm sorry?
Yeah, it's 9, something like 9 words.
But it wasn't words, so I'll get to that a little bit more. So, well, actually, I'll talk about that first. The 9 features that we used, I changed the slide around. I used to have all 9 listed out, but I kind of wanted to throw in a mixture of the different ones. But some of the features were like the readability index, the Gunning 5 readability index, the lexical density, which is how many unique words are there in the whole set of words that you use. What's the average syllable count for the words that you use? On average, how many complex words are there, meaning words that are 3 or more syllables? How long are the sentences on average? How many sentences are there? Things like this. Those are all made up in the 9 feature set. And it was meant to be a simple feature set that you can easily get, and but did a good job at determining authorship. Now, if you go into more detail, again, like with right prints, you have features like, again, spelling. You have functional words versus content words. You have structural features. Well, that was in the 9 feature set too. But idiosyncratic features like the misspellings. You look at parts of speech tagging. How many adjectives? How many nouns? How many verbs? You look at n-grams, how many pairs, the frequencies of pairs of words or triplets of words. And it was a very large feature set. How often do you spell out the word 10, and how often do you write the digits 10 for the word 10, right? So it's a variety. These are just kind of just a sampling of the features that we use. I can go into more detail afterwards if anyone would like. So 2 of the approaches that I'm going a little bit long, so I'll rush through this a little bit. I want to go into 2 of the approaches in a little bit more detail. The first is the synonym-based approach. And this is a good demonstration of actually what is a single feature type of stylometry. They're only looking at word choice, right? They're only looking at based on your choice of a specific word, given the options you could have used in the place of that word, they try and figure out your authorship. And this is a method that we actually found to be very accurate in determining authorship. So here's an example. We have 2 known authors. We have author Noam Chomsky here and author X here. Noam Chomsky writes, colorless green dreams sleep furiously. Author X writes, bright verdant grass sways peacefully. And then we have this unknown passage that says, colorful verdant dreams sleep furiously. Now, Noam Chomsky has more words in common with the unknown author, but this system actually would classify the unknown author as being author X. And the reason for that is, while there's more words in common here, the other words you could have used in place of dreams and sleeps and furiously are, according to Princeton's WordNet, there are many less options than words that you can use in place of verdant. So the use of the word verdant, which combined with the fact that there's a lot of options and the fact that it's a rarely used word, means that it's much more significant for authorship than dreams and sleep and furiously. Yeah.
I was just curious. So you said verdant is a rarely used word. How do you determine whether?
So the way you would determine that is looking at the data set that you have. And actually, here's a breakdown of how the match value is created. So you look at the shared text frequency of a word. So you look at how often a word is used by one author compared to how often it's used by the whole global set of authors. You look at the number of synonyms that WordNet presents. And you look at, when I say global frequency, I'm not talking about of all language, I'm talking about of the set that you're looking at. Okay? So if that word, for example, if verdant, for example, is not used frequently amongst most authors, but one author uses it a lot, that would mean that it's highly indicative of authorship because there's a very low global count and a very high relative count for a specific author, right? Yeah.
So if I understand correctly, then if you have passage, which has not been identified, like attributed to one particular author, you can only say that this author is most likely to be the author of that passage, but you can't really say that none of the authors in a data set wrote this passage.
Right, because and I should have been more clear about this. In these experiments we're doing, we're looking at the supervised stylometry problem, where you have a known set of authors, and you know that the unknown author comes from one of those known authors. Okay. So anyway, yeah, that's the breakdown of the how they calculate the match value, and you do this for every word in a passage, and then you add this up over all the words in the passage, and you can come up with match values for the different authors for that unknown passage. Now, the right prints method is a bit more complicated, and I can give a whole talk about the right prints method. It's a long, complex paper, but I'll just kind of go over the basic, some of the basics of it. First of all, they use a sliding window approach, where they take all the documents that an author's written, and they move down a window of 500 words at 250 word intervals. So you're kind of overlapping this so-called right print and the feature metrics between the different sets of passages. You're not using distinct passages, but you're having some overlap going on there. And then there's two basic elements to the first I'll talk about the features, because again, some stuff I talked about before. They have a baseline feature set and an extended feature set, and here we use this extended feature set, which, and here's a sampling of some of the features. And the idea of this extended feature set, on top of being very massive, is that you're using individual author level feature sets, and that the assumption here is not, oh, everyone's authorship pattern, everyone's writing style can be identified not by a standard set of features, but every author should have their own set of features that are specific to that author. Instead of using one broad set of features, you're using a different set of features for every author. So this complicates a process because you're creating a new feature set and using a different feature set for each set of authors. But it also improves the process because you are highlighting the specific features that are highly indicative of a certain author. And the way that works is through this two-step algorithm. First, you create a right print for an author. You create the feature vector, you project it into n-dimensional space, and you do some different transformations on it. And so you have this right print, right? This n-dimensional representation in the feature space of some author's writing style. And then you apply the pattern disruption. And what the pattern disruption is, in this case, I know they want to expand it, but in their method that they created, they're just using individual words as pattern disruptors, is that if a word appears in an unknown document that is not in any of the training text for that author, that's a disruptor feature, because that feature was not present in the individual author feature set. And you're applying this one, and it applies this coefficient to the n-dimensional the matrix of the author's features and shifts it slightly in the space. So you do this for all the features that don't appear in that author's feature set. So you have this combined effect of creating the right print and then also making adjustments for the features that are especially lacking. And the way that this adjustment is made and the way that this disruptor coefficient is calculated is sort of similar to the idea of the previous one, the synonym-based method, but in this one they look at the information gained in the feature, and then they also look at the shared and global synonyms, shared and global frequencies, for that feature across the whole data set. And because we're using individual author level feature sets, each comparison is actually going to be two comparisons, right? So if you have some unknown document and you're looking at the difference between two authors, author A and author B, first you have to create a right print for that unknown data set with B's feature set, and they have to create a right print for that unknown document with A's feature set, and then you're going to look at the Euclidean distance between these two comparisons in the n-dimensional space and make a determination based on that. So that's kind of a rough overview of the right prints approach. And I should say that the right prints approach, again, they've come forward with some of the most convincing numbers and most accurate numbers of any method of stylometry looking at large authored sets of any other paper that I've come across. And we've been able to replicate this and replicate it not only on data sets that they've done, but on our own data sets, and show that the accuracy is really high. And that's exciting, and it provides some interesting effects to the results. So I've talked all about that. Now I want to talk a little bit about the results. First, I'm going to talk about the accuracy. And I know there's a lot of colors on this graph, but bear with me for a second and I'll walk you through it. So first, remember I said that we looked at 4 different I should probably do this when the camera is over there. We looked at 4 different methods of authorship recognition, right? So we have the neural network, the support vector machine, the synonym method, and the reference method. We also looked at different unique sets of authors. So we had 12 authors total, and we did do it on 12 authors, but we also wanted to see, well, how would it do if there's only 8 authors? And how would it do if there's only 4 and 3 and 2 authors, right? And this black line here indicates the random chance. So if you had an unknown document and you just randomly picked what author it could be, that is the accuracy that you would get. And you see that in general, the accuracies of these different methods is far above random chance. At 2 and 3 authors, you're between 75 and 95%, which is good and accurate for, it's along the lines of what other stylometry research has shown. And even when you get down to 12 authors, I mean, some methods, like the synonym method, have almost 90% accuracy, and even the others that hover around 60%, it's not the same as a 90% accuracy, but it's far higher than the 8% of random chance. So there is identity here, there is authorship being leaked here.
I thought you said White Prince was better than...
It is better on the data sets that they were using, but we didn't find the same level of accuracy. I'm sorry, I should have clarified. We came up with different data sets to use, but on this actual data set, White Prince did not do as well with the 12 authors. And we're still trying to figure out why that is. But when we replicated like the Enron data set that they use, and we came up with our own Enron data set, and we got accuracy numbers that are almost exactly the same as theirs.
So I'm guessing the accuracy also somewhat depends on the authorship set that you have and how similar the authors are amongst each other. Is there some sort of a measure to say for this particular group of participants, they are this similar? So it'll be easier or harder?
That is a good question. We don't have a metric that we use for that, and that's part of the reason why we're trying to develop a much larger corpus so that we can use much greater numbers of authors, so we avoid that problem more. Yeah.
Do you determine that baseline accuracy by sort of like a process of elimination, where you like definitively say that this author couldn't be this other one, or is it more just sort of a likelihood?
Yeah, it's more of just like likelihood. I mean, we're using general classifiers that are going to say this is what I think is the most likely author. It doesn't start by saying this author is not possible.
It never really gets to that point where you like definitely eliminate any other possibility.
I mean, well, for each author, you're saying that this is almost certainly the author, and we're saying this is how often these things are correct, right? So we're saying that like the synonym, for example, when you have 12 different authors and you throw all the known training data at it, 89% of the time, what it says is right is actually right, and 11% of the time, it's wrong. Okay.
And these are not mean accuracies; it's just one measure, right? So that's why you don't have variance.
So I don't have variance because I didn't put it. The variance, I promise, is in the original paper, but it's not in this graph.
So were there like
Yeah, so for each one, we look at 10 different sets of 2 authors, 10 different sets of 3 authors, 10 different, so for example,
like,
except for
back to
12.
Kay's question. So for example, the right Prince was significantly different than SVM and 12 authors.
Oh, no, it wasn't significantly, no, I mean.
Were they all the same, or was only synonym was significantly different from the other 3, or?
Yes, synonym was significantly different from the other 3, but no, SVM and right Prince, like they're, at least 12 authors, there wasn't enough experiments to say that that's a statistically significant difference.
Okay.
Yeah, and yeah, I apologize for having error bars. If you look at my IAAI paper, there are error bars in that, variance bars in that. But yeah, just to reiterate, so when I say 2 authors down here, what we did was from the set of 12 potential authors, we took 10 samples of 2 random authors each, and then ran the experiment on all those sets. And we did that for each one. Obviously, you can't do that for 12 because that's the entire data set.
So I was just wondering, I realize this is not necessarily the particular study, but so you have a training data set, right? So I think in the study you have the training data set is exactly the same size for each author. Mm-hmm. But what if, so say example, you're comparing Shakespeare and Churchill, right, and you have a much larger writing sample for one of the authors, and you have like a significantly smaller sample for the other author. Mm-hmm. Would that skew the accuracy? So
that's, I see what you're saying. I mean, that's a good question. We decided to avoid that issue by having the same amount for each one. But that's not necessarily a stylometry issue or even a linguistics issue. That's an AI issue. When you're using machine learning and when you're building classifiers, if you have different amounts of data for each author, you have to make sure your classifier compensates for that. And there are different ways of doing that. There's ways of normalizing the data. There's ways of adjusting the weights on classification based on the amount of training data that you have. But that's a consideration you have to take into account when you're building classifiers. Okay. So again, this is the baseline accuracy. This is what happens when we just look at the known data. So let's look what happens when we run the obfuscation attacks through. So once we run the obfuscation attacks through, we see that the high accuracy is dropped down to that of almost right around random chance. And there's some variance, but almost across the board, it's around random chance. And this shows that these methods, as accurate as they demonstrated that they were, have much lower accuracy when you present the obfuscation passages into it. Furthermore, when we give the imitation passages that where people imitated Cormac McCarthy, the accuracy drops even more, for certain methods, and though not for other ones. So in neural networks and SVMs, the accuracy drops to almost 0. But right prints and synonym methods actually showed a little bit of resistance here. And that's important. It still is not nearly as successful as they were originally, but this is kind of the first indication we had that some methods might be able to show some resistance to these attacks. Yeah.
Have you looked at the similarity of two authors when you do the, for example, imitation of them?
What do you mean?
One of the features that you look for author one, all similarities with the two, or what is the overlap between them, with the authors?
I'm not sure if I understand your question exactly, but the question was asked before about whether or not we do some sort of metric to look at the similarity of the author training sets that we have. And
here is the effect, that's what I'm saying. I want to see what, so I think the fake author or the fake features that you're creating, is it a part of the other one, or they are distinct?
Are you talking about whether or not they actually accurately imitate the author? Oh yeah, that's the next slide. Okay, sorry. So this is the success rate in actually imitating Cormac McCarthy. Okay, so this is not identifying the real author, but this is how often these classifiers were fooled into thinking that the imitation attack passage was actually Cormac McCarthy. And you see a lot of them are very susceptible. And synonym, interestingly enough, which again was the highest, most accurate method we had before, is also the most susceptible to these attacks, right? Because one of the simple things you can do is just pull a bunch of vocabulary from Cormac McCarthy's writing, and synonym method will think that you're Cormac McCarthy. So even though vocabulary choice is one of the most indicative measures of authorship, it's also one of the most easily modifiable measures of authorship. And again, here we see...
By the right.
Right.
Were there significant differences between like 2 and 13, or were those equivalent in terms of, were they statistically different?
That's correct. So again, with 13, it's hard to, with 2 through 8, we ran 10 different tests, and then the last, with 12, we only could run one, because we only had one whole data set.
Right, but even just comparing, like, so is the 15% statistically different than 45? My guess is it could be.
Oh, yeah, so that's what I was getting at before too, is saying that right prints actually is showing more resistance to this method. So this is new work that we've done with implementing right prints here, and right prints we find that is less susceptible. It's not that it's less susceptible to, its overall accuracy is still going down, but it's less susceptible to being tricked into thinking you're actually imitating someone else, right? It distributes the incorrect classifications more evenly instead of saying that they're all Cormac McCarthy. And that's, again, significant. And we can hypothesize as to why that is, and maybe it's because that they use a much more robust classifier and they use a much more robust feature set. But the takeaway point is that there is a method here that presents some resistance for imitation attacks.
Would you expect the trend to continue? So if you had a larger set, like if you had 30 authors or something, would you expect the upward trend to continue?
I don't know, and that's one of our next steps, because we're working with a larger corpus right now that we just built, and we want to see if that will happen.
It's just counterintuitive, so it's interesting.
Right, it does seem counterintuitive that as you get larger numbers of authors, that it gets more confused and it brings it more to Cormac McCarthy. My only suspicion is that, like, when you have a smaller set of authors, or when you have a larger set of authors, the subtle drift towards Cormac McCarthy becomes more pronounced, because you see everything. I don't know if I'm doing a good job explaining it. You see everything kind of drifting in one direction, and it makes it seem more likely that it's Cormac McCarthy rather than having only 3 points and having it end up somewhere in the middle. you know? But no, it is interesting, something we're going to be continuing to explore. So what time it is? Okay. And then finally, we did some work on translation attacks. We just ran through some of the more simple classifiers and looked at, not including reference, and looked at we threw all 13 authors, we included Cormac McCarthy in this list, all 13 authors at the classifiers, and found that the accuracy didn't drop all that significantly through them, and beyond that, even though it did drop, and even if it is a significant drop, it's still well above random chance to the point where we could say that the translation attacks don't offer a large amount of privacy protection and anonymization. Yeah.
For all these attacks, did you look at how much the utility, I'm just using the word utility, the utility of the data was changed or destroyed? Like, for example, if I want to post, okay, ineffective, okay, all right.
So on top of the accuracy being reduced, we find that in many cases, and this is anecdotal, of course, like I pulled out some examples to show you, and we didn't do an across-the-board study on the quality of the text. But you see here that the meaning, when you look at these different translation methods, by the way, it's one thing I didn't get to explain, I'm sorry, in the last one. We used the baseline English one, we did it from English to German, then back to English, English to Japanese, and back to English, and then English to German to Japanese, and back to English. And this is an example. So it goes from saying, just remember the things that you put into your head are there forever, to the end saying, you are dead. That there is always said. Please do not forget what he said. It still makes sense, but it's a completely different meaning there. So yeah, so we feel that the research, the exploratory research we've done into translation attacks does not support that it's a viable anonymizing attack for writing styles.
But I guess I have this question for the other attacks as well. For like imitating, like, I guess let me back up. So there are some attack techniques that are automatic and some that the human has to do himself or herself right from the start.
Manual attack,
imitation attack, the human is more involved, and the human can maintain the semantics of the message. What was the obfuscation attack again?
So I think I see where you're getting at, and cut me off if I'm wrong. The obfuscation attack was to hide your writing style by any means possible, and you want to say, well, is the content, the quality of the writing preserved through that, right? Is that what you're asking?
Right.
Yeah. So one of the directives, I didn't say this earlier, one of the directives of the initial study when we asked people to do this is it must pass the human check. We said is that your modified sample, a human should be able to read it and shouldn't raise any eyebrows. So it's an informal measurement, but in that we're kind of saying implicitly, like, you can't just throw a bunch of words and punctuation there and have it make no sense. It has to make sense. It has to be readable, and it has to be readable in such a way that someone's not going to read it and be like, whoa, someone messed with this writing sample here. Does that make sense?
Yeah, I guess the reason I'm bringing up this question is that I'm kind of interested in this idea of having machines take a piece of text and like an algorithm spitting out, another piece of text that hopefully breaks stylometry. And the third one tried to do that, it failed miserably. And I would expect the first two to do well because the human is involved in that translation. But I don't know are there any promising techniques that you're aware of or have tried that
for automated
stylometry attacks?
In short, no. First, there's only one other paper that I know of that tried to do any sort of automated attacks, and actually, I think I'll mention it. I'll mention it in a minute, but it's not the focus of what I'm talking about their paper. But they looked at the Federalist Papers and they did some automatic obfuscation attacks on the function words of those papers, but they didn't actually modify the text. It was just purely a theoretical paper where they modified the actual feature vectors. So they modified the values and say, like, man, we're gonna give this document, we're gonna say that it had, it used the word while 10 more times, but they didn't actually try and apply that to the text and see how it would confuse the text. So I don't consider that to be, I consider it to be a good, useful theoretical approach to show how a few changes need to be made to trick a certain method of authorship recognition, but I don't think it's a good practical approach for automated obfuscation.
Has anybody tried just like for the synonym attack, for example, just replacing words with unlikely synonyms? And I feel like you could break it with that, right?
Yeah, I think that you probably could. I have not seen that tried. I think it would work, but I think also that would fail with all the other methods.
Yeah.
So
I had a question, and I don't know if it was the same question as well. Kapari asked, but looking at the attack model, and the attack model would be, somebody who's trying to post something online without being identified.
Mhm.
Right? So I was wondering if you looked at, if I do try to imitate someone else,
Mhm.
am I able to convey the same information? So, I mean, I might be able to, so, I might, you might ask me to imitate Shakespeare, I can, and ask me to describe my surroundings, but if I write, to be and not to be, I might be able to imitate Shakespeare, but it might not actually convey any information.
Right. So no, we didn't study that. The only way we looked at conveying information was to give everyone the same task, but we didn't actually have them try and convey the same message, for example, that Cormac McCarthy conveyed. And again, a lot of this comes down to, and I'm very much interested in hearing ideas about this, comes down to a lack of data. Because I get asked, well, every time I talk about this stuff, I get asked questions like, did you try this, and did you try this, and try this? And I say, no, because we don't have the data to do that. And to get the data, you need humans to actually sit down and do it, which is difficult. And I'll talk about this a little more later, but I might as well go into it now. We had all these people that wanted to help and participate, and of course, when you ask them to actually do it, they never get around to it. So we finally, to build a bigger corpus, enlisted Amazon Mechanical Turk. And we were very worried about this because, I think we have the perception that Turkers are not going to do a very good job at their writing modifications, right? But so far, we have about 25 authors in our set, and we will be releasing it publicly after we've done our analysis of it. And so far, we're pretty happy actually with the work that's come through it. And the way that we try and incentivize that is by telling them, we give them a base amount that will pay them for the passage, and then we allot a bonus amount for the quality of it. So the idea is like, okay, if you say, hey, we'll give you $5 for spending 40 minutes, we'll give you an extra $3 if it's good. You're hoping to incentivize people to actually write a good attack passage.
Sorry,
Yeah,
further
sure.
question on that. So when you say you incentivize them on the quality of it, how do you, what do you mean by quality? Because wouldn't that create a selection bias where you pick
Right.
passages where you only take, in the analysis set, you only take passages
Right.
that, humanistically.
Well, in function, we're generally giving most people the bonuses, and the only thing that we're actually making sure is that they don't plagiarize, that they don't pull things off the web, that they don't just do whatever. So we're not applying any sort of rigorous quality metrics to it at all. It's more basic quality metrics of like, did you actually do the problem? Can we tell? And you can tell by, some people sometimes will just copy the text that's on the page and paste it in, assuming that we'll never look at it and submit it. So that we can see, and they won't get the bonus, nor will they get paid in that case. But so I see what you're saying, but yeah, we're applying very loose quality metrics, and the idea is that we just want to make sure that it looks like they actually did it. Or I'd say, less that it looks like they actually did it, and more that it doesn't look like they didn't do it, if that makes sense. You know what I mean? It's a different question. So but that's an important point. So I just hit a couple of these. I'm running a little late, so I've got a bunch of stuff. Still got a bunch of stuff to talk about. I'll skip through that. Whoa, that did not translate through. Okay. I will.
Your computer applied stylometry too.
Yeah, I guess so. That's crazy. Yeah, I apologize about that. I swear it appears on my machine, but just I can explain the bars a little bit, and I'll give you a hint of what I'm trying to talk about. These graphs were meant to indicate the changes in features on different samples, and I'm bummed this didn't work out because these are cool graphs. So I know, for example, that this line here is average sentence length. And we found that a vast majority of the cases increased the sentence length by a large amount, and in some cases, some people just decreased them. This is for obfuscated passages. So we see that adjustment. And then, interestingly enough, when we pass through the imitation attack, we see that same bar, right? I'm pointing to right here so we don't lose our spot, go up all the way. And everyone shortened their sentence. I'm sorry. Everyone. This is a number of sentences. Everyone had more sentences, therefore they had shorter sentences, because that's a hallmark of Cormac McCarthy's styles. It does short sentences. You're going to get a lot of sentences packed in there. And I think another overall point that you can see, even without all the labels on here, is that, again, these are the amount of changes that happen in the obfuscation attack, and these are the amount of changes that happen in the imitation attack. So you see a much greater divergence and a much greater push in different directions from the imitation attack, and that kind of shows our original hypothesis that people are doing more modification with the imitation attacks because they hopefully have some more guidance from who they're trying to imitate. So if you want, I'll make sure that the slides that go up on the web will be properly annotated.
Were you able to compare, like, changes to certain features fooled the systems better than others, or even which features people had trouble adjusting to when they were trying to?
No, well, I mean, we have a list of like the features that were most salient, and then we can compare that to the list of the features that were modified the most, but I don't have that in the talk, I'm sorry. So one of the last topics I want to talk about, I'm running a little late, but is detecting attacks. So this is another important part of this work, is that you want to see, is it possible to, maybe you can't tell who the author is, or who the real author truly is, but you want to know if some deception has gone on. And this research was originally presented by a couple of researchers a few years ago who said that, yes, it is possible to detect it. And these are the same researchers that did the Federalist paper work I just talked about, where they modified the feature vectors. So they modified all the feature vectors, and then they tried to examine whether or not it's possible to detect attacks using this unmasking approach. And it's kind of a frustrating concept. I found it to be a frustrating concept to wrap your head around, because there's a lot of repeated word usage, but I'll try and explain it as best I can in the time that I have. So remember the Federalist Papers, you're debating between a Hamilton document and a Madison document, right? You have Madison, the true author, and Hamilton, who didn't author, but that actually doesn't matter. You have a Madison document and a Hamilton document. And these graphs are meant to show the accuracy in distinguishing between documents as you remove the most salient features from the classifier. So if you look at the blue line with Hamilton versus Madison, you see that in the beginning it's really easy to distinguish the difference between them because their writing styles are very distinct. And as you remove the most salient features from the writing samples, the accuracy in distinguishing between them slowly decreases. And we'd expect this, right? Because you're removing valuable features that distinguish the writing style, and you're removing them, so the accuracy will slowly go down. When you take two different Madison documents, you see the accuracy is always bad, around 50% in distinguishing between them, because they're actually the same person. So if you're trying to distinguish between them, you can't. And finally, when you're looking at a Madison document versus an obfuscated Madison document, a Madison document that was modified to make it look like Hamilton, this is like a deception document, initially the accuracy in distinguishing between them is very high because a bunch of features were modified. But as you remove the most salient features, the accuracy drops very quickly down to that of random chance. And the idea there is that the modified document, as you remove these modified features, it's going to become clearer and clearer that it's actually, an original Madison document if you try and compare the differences between the two. And just another quick, if that didn't make sense, if that didn't make sense, here's just a simple graph. So say you have a Madison document and an obfuscated Madison document, and the tan circles are unmodified features and the colored circles are modified features. So these documents look pretty different. But as you remove these features, as you remove the modified features one by one, you end up getting documents that look pretty similar to each other, and that's an indicator of deception.
So in the previous slide, for Hamilton versus Madison, as you remove the identifying features, it goes down and then it goes up.
Yeah, I mean, I should clarify again. This is from their work, not mine. Okay. Yeah, this is Kakmarsik's and Gammon's work, and we did apply it to some of our work, which I'll go over in a second. So I don't have the data to explain that, but I
would think you could think of it as a trend rather than a. Yeah,
exactly. The point is you're looking at the general trend, not the changes from one to another. I mean, if anything, I think that shows a weakness in the classifier by highlighting certain features more than others. Ideally, if you had a perfect classifier, it should always be going down, right? We've not really been able to duplicate these results. Of course, the main reason why is, again, due to an inadequate corpus. They were able to automatically modify a whole series of documents, and we are using actual practical manual methods. So while they can use a whole bunch of Madison documents versus a whole bunch of obfuscated Madison documents, we only have a whole bunch of known documents and then one small passage for unknown. But we were able to distinguish between regular passages, obfuscation attacks, and imitation attacks with high accuracy by training the classifier on different imitation, obfuscation, and known passages. And it could say, oh, this is probably, we're much better at at detecting imitation attacks and obfuscation attacks. They say this is probably an imitation attack and this is probably an unmodified document. But there's something unsatisfying about that because we can't be sure that it's not simply picking up on the differences in the content of the passages, right? So it might notice that, for example, one of the things in the earlier in the earlier slides that was modified heavily is personal pronouns. In the attack passages, personal pronouns went way up, and that's because we gave them a specific task that deals with speak about your neighborhood, speak about your morning. So people are going to use he and she and I and things like that much more often. Now, the only method that would have affected is right prints in that example, because the other three don't take into account personal pronouns so much, but still an important. So this is work in progress. I just wanted to share some of it. I think this idea of deception is really important, and we're making some progress on it, but it's got a ways to go. So, yeah, I'm just going to skip a little ahead to what's coming next. I have about 5 minutes left. So we have 25 authors and counting in our new corpus that was built by the Mechanical Turkers, and we're doing this again because finding volunteers is hard. We get a lot of questions saying, have you looked at different languages? Have you looked at this and that? We're hoping that if this data set is useful, that we can continue doing work in this regard, but I would feel more comfortable if we were using a data set that was all volunteer-based and not being paid for, but I'm reserving my judgment until I get the final data set and see the results from it to see how the people did. Yeah.
I have a couple of general questions. So firstly, how would you galvanize, say, the security community to get behind this problem? I feel like, so I've been interested in it, and there are some people like you, or maybe you're the only one interested in this. And I feel like unless there's like a clear demonstrated attack showing, look, here's why we really need to worry about stylometry, will this just remain like a fringe research problem, or or can we do something about it? So I feel like what I'm saying is I feel like we're missing that one, like say maybe landmark paper that comes once in a while to remind people that, look, this is why you really need to worry about it. You've all been using Tor or whatever. Right. For some reason you're all crazy about Tor, and you use Tor to post stuff on WikiLeaks or Wikipedia or whatever. And look, we can de-anonymize all of them. I feel like we're missing that. We
need a demonstration of harm, is what you're saying. Yep. Yeah. No, I think that's a good point, and I think it might come to that. I mean, I was very much so in terms of interest, we've gained a lot of interest without demonstrating that, at least from individuals. People. I get a lot of questions about this work, and people seem really interested about the implications of it. It's a tough line to walk down, right? Because I also don't want to go de-anonymizing a bunch of documents for the sake of proving harm. I mean, I understand the purpose of that. And so we were hoping to demonstrate that on innocuous documents, like in this report. But I understand how that might not be enough, and that you might need to show a real life scenario to get people kind of freaked out.
It doesn't have to be complete real. I mean, it could be just a very relevant. I mean, you could have synthesized data sets, or you could collect them, with IRB approval and whatever from subjects. But I feel like it's not hit the point home yet in a realistic enough setting.
I guess we could find a more realistic scenario that doesn't have maybe serious implications to the privacy of the individuals involved.
And then I have just another comment. Any other questions, Mike? I'm quite curious about why you're using the terminology of attack. In my mind, I keep thinking of this as a defense against stylometry. The attackers are the people applying stylometry to de-anonymize me, and I'm defending myself against that. So I'm defensive techniques. This
is a debate that we've had in the lab a lot, and that the fact that people have suggested that it doesn't fit the formal definition of attack, and I understand that line of reasoning. I mean, the primary reason we use it is because the primary reason, and maybe this is not a very good one, has been for historical purposes. We've said in our applications and in our solicitations for volunteers, we've used this title, we've used this terminology, and we didn't originally come at it from the security community perspective, so we weren't using attack in the traditional security definition of the word, and more of a general idea of looking at attacking a method of artificial intelligence, a method of classifying. I mean, this came out of original artificial intelligence research, and yeah, so the only thing I can say to that is I see your points. I think you have some good points, and it's been a debate that we're continuing to have, and you might see that change. But I appreciate you bringing it up.
Have you looked at using, or do you know of anybody who's looked at stylometry to look or provide a metric for either phishing or spam documents, the textual documents?
So not stylometry specifically, like I haven't seen people saying they're using stylometry, but certainly phishing detection algorithms out there and spam documents out there use machine learning and use machine learning classifiers to classify, word frequency counts and stuff like that, which could, I guess, in some way be considered stylometry. But I haven't seen any implementations that use the more verbose, let's say, feature sets that current methods of stylometry use to detect phishing attacks.
Yeah, just because I'm thinking many of the phishing attacks have structure, English structure, that is generally different from what you might normally see here. And I know this would be one of the plethora of spam tools. But as a side note, then, Apu, if they started doing this might better the attack defense thing, because now we just have spammers trying to get around the stylometry. So in the end, it'd be an attack.
Hey, Mike, why don't we let you just take a minute or two to wrap up, and then if people have questions.
Oh, sure. Yeah, no, we can just jump into it. I pretty much got that. I'll just hit on real quick that I also have a job at the FTC, and this is unrelated to this work. I just want to make mention of it. And I bring this up only because through my time as a computer scientist, I think I struggled for a while to kind of find some things I was interested in and find people that were also interested in the realm of tech policy. And it's exciting to me to start working for the Federal Trade Commission as a technologist, where we investigate unfair, deceptive privacy practices of different companies. And it's a really interesting job where I get to interact with the different people, the different lawyers in the division, and the different lawyers and commissioners at the FTC to try and make policy changes in a positive way for general consumer privacy. And there have been, here's just a few hallmarks of my job is that, I have a responsibility as a technologist not to just say, oh, that's technically accurate, that's not technically accurate, but to go out, do research, find violations, and present them to the lawyers and say, this is an important issue that we should be looking at. This is a company that we should investigate. Here's why. And also, here's the basic legal theory that, that I think we can operate under to investigate this company, even though I'm a technologist and not a lawyer, as I work with the different lawyers on their cases, whereas each lawyer might have 3 or 4 investigations that they're carrying out. I might work on a dozen different investigations with, half a dozen different lawyers. My role is to keep the staff educated on current trends in privacy, to help construct documents that are technically sound, legal documents that are technically sound. And generally, the role of a technologist and the role of a technical advisor in Washington seems to be fortunately for now, but unfortunately for the past, a new thing. Like the Division of Privacy and Identity Protection existed for 6 or 7 years before they even had a technologist on staff. And then you have technologists that come in and say, hey, we should be looking at cookies. We should be looking at opt-outs. And here's why. Here's what a cookie is. Here's what behavioral tracking. Here's how behavioral tracking works on a technical level. This is what an HTTP header is. This is, all these sorts of things that they just aren't aware of. And you have to, on top of educating them on them, explain why they're relevant and why they're important. Because these privacy issues are only getting more technical and more complex, and the implications of them can be harder to see if you don't look at them with a technical mindset. And it's been an exciting thing to be doing this stuff. They also recently hired a chief technologist, Ed Felton from Princeton University. Some of you might be familiar with his work. He's been a great asset to the FTC as well. And I'm not here to promote like, oh, you should get involved in government, but just to say that there's a lot of work that needs to be done in the form of computer scientists acting as bridges to other communities and other areas of research and government and policy and NGOs and nonprofits and all that, more avenues outside of traditional industry and academic tracks. So keep that in mind as an option if that's the kind of thing that you're interested in. And if you want to look at the kind of stuff we've done recently, all of our stuff is not public until we close it out, but we recently released a privacy report, and we have a few different settlements that came out recently with Google, with Twitter, and with Chitika about some deceptive practices they were engaged in. So, feel free to ask any questions. Yeah.
Where can we read about these?
You can read all these on the ftc.gov website. I'm trying to think if there's a better thing off the top of my head. Now, if you Google any of these company names and FTC, you're going to see news articles about it. When these settlements come out, they usually hit the front page of the New York Times. The Wall Street Journal has a really excellent series right now called What They Know, and it's all about online privacy. They cover some of the FTC work there, and also.
Time had a similar series too.
What's that?
Time magazine, like a couple
Yeah. Yes. Yeah, they did. So there's a lot of good work on there. If you just do some quick searches, you'll find all the stuff about it. Okay. So that's it. Again, contact me anyway you see fit on here. Go to our website. You can see the research that we're working on. We have a lot of other research that we're doing now that doesn't have, at the moment, direct privacy and security applications, but has to do with social computing and things like that. If you're interested in that kind of stuff, come talk to me or check out our website. And thanks a lot for having me.
Mike, thank you so much for being a bridge to Washington and also a bridge here to Bloomington. There is time for questions now, but if anybody needs to go, feel free to head out. But I think you have at least 10 or so minutes.
Yeah, I think to want to
chat afterwards informally.
Sure.
Some features like syntax and structural features.
Mm-hmm.
Can you make some examples and say how you extract them?
How you what?
Extract them from the
Sure. So, I mean, by structural features, it can be something as simple as the sentence length, the number of words in a document, the ratio of unique words to non-unique words. But one thing that's important to remember is that when we're talking about the features here, most of our work is, almost all the features are, the largest scope of the feature is at the sentence level and below. Only a couple of features look at the document level, and we don't have any features that look at the paragraph level. But I would consider structural features, for example, to be things like narrative structure, potentially, which we don't incorporate here. When main ideas are presented in the text, the flow of the dialogue, when things are discussed, these are important structural features that, frankly, I don't have any easy way of extracting at the moment. But the easy way to extract sentence level features is there are a lot of good toolkits out there. The NLTK, Natural Language Toolkit for Python, is great. You can very easily extract sentences. Syllable counts you have to kind of write your own function for, but I'd be happy to share that. And a variety of other structural features that you can get just from basic, what we would consider shallow natural language processing. So not deep natural language processing where you're trying to get at the understanding of the text and the meaning of the text, but shallow in terms of where words are used, what words are used, the parts of speech tagging that's going on, the joining of verbs and adverbs, stuff like that. No, we don't. We not in these. Not in these. Again, it's not to say that's not a valuable feature, but we don't cover it in these classifiers. Other than, I mean, you could say we check your grammar in so much that we would detect if there's excessive comma use or excessive semicolon use because, we count the punctuation, but we don't run through a grammar checker and count the errors or anything like that. So, yeah.
With the data set that you have, did you look to see if particular participants were better at using one of the two techniques in building the system? And if so, can you extract what were they doing that was good? So you can actually give advice to people who are trying to... Right.
So we did find that certain people were more susceptible to being classified than others. And but the results were kind of what would be what you'd expect, and that the people that modified, I think in our informal analysis of this, it's like, you do want to shorten your sentences. You do want to use less complex words. You don't want to give away so much information in by using, reusing strings of words together.
So you do have guidelines that you can give to
Yeah, we have not crafted any formal guidelines, but we certainly could come up with some. But we still feel actually that the best guideline you can have to hide your writing style is to try and imitate someone else's distinct writing style, because that's going to give you so many clues that you didn't really realize, and maybe you don't even realize you're doing. Because I don't know that, one question I kind of wish I'd ask people is, do you feel one passage was better than the other? And if people said no, that would be really curious, because they clearly did better with the imitation attacks than the obfuscation attacks. So.
So my sense is you've been talking about documents that, 500 words plus certain larger text. Have you looked, can you string together a bunch of shorter authorships by, I'm looking at a tweet stream or a series of emails, and sort of get analogous results?
So yes and no. Yes, in that we have found that if you combine together a lot of small documents, that you can get some solid authorship analysis out of those documents. Like if you take For example, Right Prints did eBay comments. They looked at like tons and tons of eBay comments and just combined them together and got good results in those. And we've done results on emails where emails you might have 500 emails, but some of them are only a sentence long, and we would get good results. But if you're trying to classify an individual tweet, for example, based on a history, that's much more difficult because there simply isn't enough data in that tweet to give you a very accurate authorship indicator.
But a public tweet stream could serve as a data set to identify an anonymous document.
Potentially. So we have not done explicit research that looks at the cross-domain application, like what happens if we train on a tweet stream and then examine a document, like a formal document.
My hypothesis is actually that you wouldn't get good results like that because you're constrained in the character space. People write very differently in those short sort of character spaces.
I was going to say,
I think it's a really super interesting research question, but my hypothesis would be that it would be.
Yeah.
That was sort of another question I had, is I sort of had the assumption here people were writing in some very comfortable way for them, and what happens if you force me to write a 500-word document on my Android phone?
Right.
You know.
Yeah, sure. No, there are a lot of good questions, and that's one thing, I mean, there's certainly more experiments that we can run than I can humanly do. So I'm hoping that, I always try and talk about this and trying to generate some interest because running some of these experiments wouldn't be terribly difficult, and especially when they're making these corpuses available. So we really hope that people will kind of take that stuff and try and run their own experiments and see what they can make from it. Yeah.
Very quick question. You mentioned that you're looking at spelling. What do you use to look at spelling?
We'd have a list of commonly misspelled words that we're using. My colleague Sadia is the one that implemented that. If you send me an email, I can ask her and I can get that to you. Yeah.
What was the translator that you used? Was that like
Those results were Google Translate. We did it with Google and with Bing. So that's another important thing. I mean, we did, so those translation services are like statistical machine learning translation services that also incorporate people's corrections. So it's not just doing like a word by word thing, but looking at the web and how documents are trying to find correlating sentences. So generally, they're really good translators. We didn't try doing it on a simpler translator like an old Alta Vista, like a Fish translator. But given the changes in the meaning of the documents that we got from Bing and Google, we didn't think it would be. We thought it would probably be much worse if you actually used a poorer translator. It might be more obfuscating, but
Google actually uses kind of research to modify and perfect their translator?
They don't use this research, but they do modify them. And so I don't know if you ever noticed, if you've ever, if you go to Google and translate a web page and you mouse over a sentence, it'll tell you what the original text is and allow you to suggest a better translation. That's one of the ways. They use a variety of different ways to improve these translations. Okay.
Thanks again, Mike.
All right. Yeah. Thank you.